Hey guys, so I wanted to make a quick video about some of the problems from Desmos from week 4. There were a couple of slides that seemed to be causing people a couple of issues, so I wanted to go through them really quick. So uh, this first one is deciding whether what you have on the graph is a function or not. Well, this is just a matter of using your vertical line test. And if at any point you take the vertical line and it intersects it more than once, then it is not a function. So you can tell right here, see where it's like a line right there, then it's not a function, because for every x value there's more than one y value, which means it's not a function. And same goes for down here. You know, a vertical line is not a function because it has more than one y value, corresponding y value. Whereas on this side, if you were to do the vertical line test on this parabola, well, for every point that you intersect the parabola, it only has one corresponding y value. So that's what makes that a function. And then this horizontal line, similarly, if you were to do vertical line test, it only has one corresponding y value. So that's what makes these two functions. So that's that one. So now, let's see. So now the next problem was this one, where you needed to find domain and range. It seems like this domain and range causes a little bit of confusion, but domain is just all your x values and range is all your y values. So for this one over here, the domain is from x to y, or sorry, from this x to this x point. And so that you can see is from -1 to +1. Now the other thing to notice is that this left circle is an open circle, which means that point is not included, which is represented with a parenthesis. But this other point on the right is a filled in circle, so that's represented using a bracket. And so that's why the domain is -1 to +1, parenthesis and bracket. Now the range is just a matter of your y values. So you're just evaluating it from here to here. Now, so this is from 3 to 4. Y equals 3 to y equals 4. The reason that 3 and 4 both have a bracket is because this dot over here is filled in, which basically, because it's the range and it's just your corresponding y values, it basically overrides this open circle, because it's saying that point at y equals 4 has a filled in circle no matter what, so it is included in the graph. And so that's how you do domain and range. This one over here, for this domain and range, we have -1 to 1, so it's the same graph, but the points are different. So the filled in circle is over on the left, whereas the open circle is on the right. So for your domain, which is your x values, the point on the left is included, so represented using a bracket, and the point on the right is not included, so used an open circle, so the parenthesis. So really all these graphs are essentially the same, except the points at x equals -1 and x equals +1. So this graph here, both circles are open, so neither of those points are going to be included in the domain. But the range at y equals 3, because it actually is going through the point at y equals 3, it is going to be included, which is why it has a bracket. Whereas at y equals 4, both the circles are open, which means they're not included. And then with this graph over here, both points are filled in circles, so both points are going to be included in the domain, and then the range, y equals 3 and y equals 4, are included. So then the next one, let's see, this guy, so you had to figure out where your graph was increasing. So you basically just had to take this, drag it over to find where your function is increasing. And it's literally just evaluating at what point where x equals, so down here is your inflection point where your graph changes from decreasing to increasing. And so from this way to this way, you know, that's decreasing. But from here, this exact point is your inflection point that changes your graph from decreasing to increasing. And so that's why this whole section is the correct answer, because that's the section where your function is increasing. So finally, the last one that seemed to be a little bit more difficult was this one. So this is decreasing, so it's the opposite. So it's the point of change where your function goes from increasing to decreasing. So on this side, our function is increasing. Here, let me try that again. Our function is increasing. This is your inflection point that changes from increasing to decreasing. And so that's why at this point, that is where we are highlighting, because that's the point of decreasing. That's the answer to the problem, is where your function is going from increasing to decreasing. So that's it for these ones. If you have any questions, please feel free to ask. Otherwise, thanks for watching.